In this video, we're going to solve the same four problems that we did in the previous two videos, but instead of using the systematic split the middle or factor by grouping process, I'm going to just do them intuitively. Now in this quadratic, the lead coefficient is 3. 3 is a prime number, so there's only one way I can get 3x squared, and that's going to be 3x times 1x, or 3x times x. Now looking at the constant, there's a negative there, so I know I have to have a plus and a minus. I'm going to guess that the plus goes here and the minus goes here. And this is a 4. There are two ways I could multiply two numbers and get a 4. 2 times 2 or 1 times 4. I'm going to guess that the 4 goes here and a 1 goes here. Now to check to see if I have the correct factorization, I'm going to factor or multiply these two binomials out. 3x times x is 3x squared, as we expected. 3x times negative 4 is negative 12x. 1 times x is x, and 1 times negative 4 is negative 4, which we knew it would be. So I'm going to add the two rows, 3x squared minus 11x minus 4. That is my original trinomial, so I know I've got the factorization correct. So using the zero product principle, 3x equals negative 1, x equals negative 1/3, or x equals 4. So I'll now go on to the next one. Again, I'm lucky. 5 is a prime number, so I know I have to have a 5x times an x to get 5x squared. So now I have a positive number here for the constant term, so I know I've got to have a minus and a minus. So now I need to get a total of negative 32 here. So I kind of have an idea from doing the problem before using the other process. So I'm going to go ahead and say minus, so I'm going to say minus 6 here and minus 2 here. So to check the factorization, 5x times x is 5x squared. 5 times negative 6, or 5x times negative 6, is negative 30x. 2 times x is negative 2x. And negative 2 times negative 6 is positive 12. If I add up the two rows, I get 5x squared minus 32x plus 12. So using the zero product principle, 5x equals 2, x equals 2/5, or x equals positive 6. Going on to the next one. Again, a prime number for my lead coefficient. So the only way to get a 7x squared is multiply 7x times 1x. So I know I need a negative 24, and I have positive in the middle. So it's got to be negative, negative. A correction. I've got to have a positive, and I've got to have a negative. So I can try negative, positive. So to get negative 24, there's several different ways I can do that. I can go 6 times 4, 3 times 8. So I'm going to try 8 and 3. So 7x times x is 7x squared. 7x times 8 is 56x. Negative 3 times x is negative 3x. Negative 3 times 8 is negative 24. If I add the two rows, I get 7x squared plus 53x minus 24. So I know I've got the correct factorization. So using the zero product principle, 7x equals 3, x equals 3/7, or x equals -8. Now, I kind of remembered the previous problem. I could have put an 8 there and a 3 here, and when I checked it, I wouldn't have had the right factorization. So then I could go back and try again. So here, no longer a prime number. So there's several different ways I can, or two different ways I can get a 6 here. I could do 6x times x. And let's just try that. I have a positive here and a negative here, so I know I need negative, negative. So it's either 5 times 3 or 3 times 5. So let's try a 5 here and a 3 here. 6x times x is 6x squared. 6x times -5 is negative 30x. Negative 3 times x is negative 3x. Negative 3 times -5, positive 15, which we knew it would, but this isn't going to work. So I have a negative 33, I need a negative 19. So no big deal, just start back over. And I'm going to get rid of the 6, and we're going to try 3x and 2x. So here I'm going to try a 5 and a 3. But here I can see the 3's would divide out, so I kind of know that's not the way it would work. So 3 and 5. 3x times 2x gives me 6x squared. 3x times -3 gives me negative 9x. 5x, or -5 times 2x gives me negative 10x. -5 times -3 gives me 15. And I can see already this is going to work. So that checks with the original trinomial. 3x equals 5, x equals 5/3, 2x equals 3, x equals 3/2. So you can see we had a systematic system where we could solve these, or we can do them intuitively. We may have to start and stop, but in general, you can usually solve these faster using this method. That concludes this video. The next video will include special cases.